And also, I think we did forget to mention we had a really good help with the planning for this event, especially Steve Cooper took a lead on that, and then also Dennis Dvorak and Kevin Clethermis were involved from Federal Highway, as well as all of the MnDOT folks. So thank you to you guys especially. Um, I wanted to give a brief recap of yesterday. Some people weren't able to attend. We did actually have 89 attendees. We were able to download the participation list thanks to Lauren and Jeff Brunner. They helped me figure that out. And an average of an hour and 46 minutes duration for that morning session. We haven't run it for the afternoon 2-hour session, so that means people were sticking around to hear everything, which is great. We started with it's always nice to have a big picture perspective. Glenn does a great job kind of taking sometimes the analysis that we're bringing into the weeds and putting it in perspective of what it means for DOTs if we can achieve use of this technology for acceptance. And Di went through some of the housekeeping items in terms of our contract and where we're at, did a great job with that. And related to that, I touched on some of the website updates and how we're tracking progress online now, and then also some of the tools that we're going to start posting for analysis to the website, which will hopefully come in handy for states who are either just starting to get experience or more experienced states who just want a template to use for some of the more kind of routine percent conformance type analysis. And we'll plan on putting training videos out for the analysis stuff, similar to what we've been doing for the testing protocols. I think I saw a hand go up. Maybe that was on accident, but if you have any questions, go ahead and ask. I went over some of our current DPS protocols and where we're at in trying to develop an AASHTO spec for use of DPS as a acceptance tool for density. And it was really great to hear from the UNH team, Joe Sias and Ishan and Adam Hand. Will be consulting for them, and they did a great job of going over some of the kind of much needed things that we need to get done, including statistical analysis and justification for the different methods that we're using, as well as kind of refining our protocols and our terminologies to make it a little bit easier to communicate to everyone where we're at and where we need to go with everything. So thanks for that. And after lunch, we went into a little bit more analysis. I touched base on some of the new live analysis that you can do and our experience with that this construction season. Our experience doing a pay for data type approach using the spec that was introduced in the morning session. And then also talking about some of the challenges. You know, everyone knows one of the big things with getting this for use as acceptance is to be able to figure out when we do experience bias between our predicted air voids or predicted density and what we get when we have cores. Being able to really mechanistically understand what's causing that and address it with our spec. So, and then we also talked about some of the new analysis tools that have been greatly simplified through the work that's been done in this pooled fund. Leslie and Hoda both did a great job. Hoda talked about some of the work that they've been doing in their research group, and Leslie's been of great support with the loan program, so that was nice to hear from her. And then Prashant, to be able to kind of piggyback on that and talk about some of the experiences was great. And finally, NCAT has been doing great work with precision and bias and operator certification type work, and we were able to hear a lot of the results of their work. So I'm excited for the program today. We're going to get a little bit more of a chance to hear experience from the different states, which I always think is the most fun part of this type of work, is to just see how this technology is working, what's not working, that sort of stuff. So some of the more experienced states who were able to collect data this summer are going to present. New York, Thomas Kane, Ohio DOT, Craig Landefeld, and North Dakota DOT, who's recently gotten quite into this technology, and it's exciting to have them have some field projects to report on here. We'll get into some contractor and consultant perspective stuff, which is always very valuable. So we're excited about that. And then in the afternoon, we'll hear from Steve Cooper and Federal Highway and move into something that I'm excited about, which is getting technical working group together to try to attack these problems together. So with that, I think I have one more minute. I just want to warn pooled fund states. I am going to go through the list of financially contributing agencies and technically contributing agencies for you to give an update, even if you don't want to share an update, just even if you have any feedback, that things that you like that you're seeing in the pooled fund, or even more importantly, things that you'd like to see that you're not seeing. This is your time to just give at least some feedback so we can make sure all of the states are feeling supported and we're moving in the right direction. So, and then the last thing, warning wise, is the last session is going to depend on participation. So please feel free to participate in that last 30-minute session dealing with the technical working groups, and just put your email, put maybe TWG and your email in the chat, and Mercedes will record it. And that doesn't sign you up for anything. It just means you're going to get an email for the kickoff meeting when we do start those technical working groups. But that'll be a good way for us to record who's interested in being involved in those meetings. And you'll get more details on those later. And I'll put my email in the chat as an example of what we want to see if you want to be involved in those. So with that, Thomas Kane from New York DOT, do you mind going first?
Hey guys, how are you?
Good.
I'm not going to do much talking today because we have a few new people in the group. Brendan Rock, we're starting a new non-destructive evaluation group in the Bureau. So he's going to get much more involved with some of the pave scan work. So we're going to have him kind of do his presentation, or I should say the presentation for this 2021 year. He comes from the radar world, doing a lot of our deck evaluations and some of our on-grade stuff. So it's just a small leap to the pave scan side. So I'll let Brendan give his presentation.
Thank you, Thomas. Brendan, do you know how to share your screen?
Okay, good morning. Not quite.
It's in the upper right corner. There's a arrow pointing up.
All right, here we go. Okay.
Very good.
Think we got there?
Yeah.
All right, it's showing okay. All right, yeah, so like Tom said, I'm new to the DPS, but not new to GPR. So we're going to be going through basically what we've been working on for the last couple of years and what we plan on doing down the road. So 2020, we started out DPS with 3 jobs. We were collecting over the entire mat and reporting 100-foot segments. 2021, we increased that. We did 11 jobs, about 11 jobs. We're still going through all the data. Some of them actually got pushed off into 2022, just some contract issues. But yeah, about 11 jobs for this year. And then in 2022, looking forward, we're looking to increase our use again, hopefully get into some more D contracts. And we also have some changes to our specification, our special spec for those new jobs that we're taking on. So we're reducing our data collection, which I'll talk a little bit about later. But we're going from the entire mat down to 1 mile or 50% of the area, whichever is greater. We've added a requirement for a summary sheet for core locations. That's something we started doing this year. It worked out really well, so we're adding that in to the spec. And so that's going to be give us the ability to compare some of the core, the nuke density gauges, and the DPS a lot more efficiently. And then we're moving forward, actually not in 2022, but ahead of that, we're going to be doing a reduction in the number of pucks that we're generating. Our old spec was calling for 2 pucks at 7 different compaction numbers, and looking to reduce that a little bit now that we have some more experience with it. So continuing work from what we've been doing in the past, continuing to develop our specifications from a QA point of view. That's a little bit touching on what I was saying before about reducing the amount of data that we're collecting. As everyone's aware, we can produce just a tremendous amount of data with this. And from a QC point of view, that's phenomenal. But from the agency perspective, you know, now that we have some more experience, we want to look towards how we're going to actually use this from a QA acceptance side. So moving our specifications in that direction, at least a little bit at a time, is what we're working on. Active promotion is a huge one that we've been doing. You know, I've been involved with the DPS officially now for about a month, and I think we've done 3 presentations already to, you know, different regional leadership as far as internal to the department here, but also to contractor groups, consultant groups, and looking to bring in some more producer input as well. So, you know, that's a huge effort for us, especially, you know, bringing more people on. Getting the contractor buy-in is awesome, and also just the, like I said before, the regional leadership, as this is rolling out more and more, making sure that they know what it is before they see it is great. And, you know, we've had really great feedback every time we've done a talk. You know, just last week we did 2 presentations to a regional group and a contractor group in back-to-back days, and you know, we got into what we were expecting to do with this technology from the agency side, and the contractor groups right away, you know, just jumping in with, well, you know, this could be a great QC tool like this. You know, it's incredible how much information we can get right off the bat. So it's just been a really great feedback every time we've done that. So we're looking to continue to promote it, at least in New York, as much as possible. And then the next thing, evaluating trends. So that's kind of touching on what I was mentioning before about the summary pages from all the jobs that we've been doing. And again, from the QA point of view, we're looking at how we're going to test, you know, what our procedures are going to be and what we're going to be looking for as far as acceptance. So the first thing that we've been hitting on is comparing, you know, the DPS, the nuke gauges, and the core results, and just seeing what our, you know, the comfort level with where the DPS falls and into, you know, what we currently have, and what the repeatability of it is. And I think someone said yesterday is, you know, really important is to not hold this to a higher standard than what we already are doing. And that's just a hugely important point, because, you know, if what we're doing now is great, and if we're getting more data in between, we just need to make sure that, you know, we're not holding it to a tighter standard than we already have. So making an improvement is just as important. So these are some graphs of some of the trends I'm talking about. This is just 2 days comparing joint cores and mat cores. And this is something we're doing as we database all of our information from the last year, which we're still going through. We're making these comparisons. So this is just a couple of days that I thought were pretty good illustration of what we're looking for. And one thing we've been noticing as we're going through these is we're getting a lot better consistency with the mat cores than with the joint cores. Now, that's not to say that, you know, the DPS is not appropriate or not accurate in the joint cores, but we do see more erratic results basically in the joint cores. This illustrates it pretty well. I think the gray lines are the DPS results, and you can see in the top two, the joint core results for 2 days. They still correlate well to the data, but it's just not as consistent as what we have for the cores and the nuke gauges. Whereas if you look down into the MAT cores on the two bottom graphs, it's correlating very well. It's the data is where you'd expect it to be, but it's also as consistent as the other two tests. So that's kind of something we're going to look at further. Like I said, we're still going through all the data. Want to see if that trend is consistent across the state, across jobs, across mixes, things like that. But with that information, we also started looking at how we're measuring the DPS in these core locations. And we're doing 4 different tests. And if we compare those, you can see a similar trend. So these 4 different, the SLST, RLRT, that's the static, longitudinal, static, transverse, and then rolling, longitudinal, rolling, transverse. So we're collecting those, all that information 4 times. And actually what you saw on the previous slide here is an average of all those results. But if we go deeper and look into what we're seeing with those individual tests, it kind of mimics what we saw before. The MAT, they're all right on top of each other, which is great. If we see that consistently across many jobs, we, have the potential down the road to choose maybe just one of those, whichever one is best, and move ahead with just that, and we can reduce the amount of testing because we have some comfort level in the fact that they're all pretty repeatable. But again, on the joint side, you can see that data is a little more erratic. And again, at each individual core location, you see pretty good correlation between the two, but it's just, like I said, a little more erratic. And if you notice, the rolling transverse, the yellow line, is the one that seems to be out of the pack, basically, for these two. And that is, reflected in several of the other days that we looked at as well. So again, we're looking to see if that is something that's consistent from job to job, and maybe look more into why that rolling transverse measurement is maybe less reliable than the others. But again, that's something that require a lot more investigation down the line. So developments in our program, like Tom had mentioned earlier, we have done some reorganization here in Materials Bureau in New York, and freed up a couple people to have a work group that's dedicated to GPR, non-destructive evaluations in general. And we're diving deep first onto the DPS project. That's going to be hugely important for us. Like the just having more resources dedicated to this, putting more time into it, we'll have the ability to do these deeper dives on some of these eccentricities in the data, shall we say, that we previously weren't able to investigate any further. So that's a huge development on our side. Statistical modeling of data, I think, Kyle was mentioning this earlier, we're starting to get into this, and it was great to see the tools that he was presenting yesterday, and you definitely want to start going through some of those as well. We have made our first pass at doing some statistical modeling of our data. Previously, I was talking about the coring locations, but we also have our 100-foot segments as well. And the first thing we're doing is density histograms. Like I said, this is our first pass. It's a visual representation of the data that we have. It's really nice. I chose these 4 segments to kind of show what we're looking at. The first segment you can see, and let me put the bars up so that's actually increasing compaction as you move down. So it's 0 at the top, 100 at the bottom. So that first line right in the middle is 93%, which is our specified compaction. So ideally what we would see is, a line of dark green cells all the way across at that 93% line. Obviously there's some variation as we go through these. The first 100 feet, you can see there's a lot of variation in the compaction. There are some dark green, but there's a lot of spread. And as we move through the day, the second 100-foot segment got a lot tighter, and we can see moving across that segment, we're kind of dancing with that 93% line, as you'd expect. And then as you move farther, the compaction actually decreased a little bit, so it's moving up. So this is kind of something we're looking at, and again, applying it back to our specification effort and how we're going to utilize the data that we have. This is our first pass, and I think it's a great way to visually represent what we got from the data, rather than just all the thousands of lines of individual data points that we get out of this. This gives us a nice way to look at it, or at least initially. And like I said, Kyle, I want to go through some of your spreadsheets as well. They look great. So some of the challenges that we face this year, and that we're going to be continuing to work on, limited resources with our data collection. We've got one consultant group in New York. They've got 2 meters. So 2 groups going around doing data collection, and they've been great. But as I said, we scaled up from 3 to 11, and we're hoping to do more next year. So we're starting to reach the limit of what their capacity is with just 2 teams and 2 meters. So while we're looking to push ahead as aggressively as possible, we are going to hit a point where the capacity of the consultants are going to be reached. So we're looking at different ways that we can handle that. Data turnaround time, as we start increasing the expectations on the consultants as far as these summary reports, that's going to be an issue as far as how fast we're going to get the data to start looking at it. And then from our side as well, how long it takes us to turn this data around and run these trend lines and all that. That's also an issue, but I think that's something that we've started to address with, again, this new group and dedicating more personnel to this. So working on that. And then the last 2, developing specification requirements and investigating unexpected field data. Again, those are 2 that kind of fall into the purview of this new group. So as we have more personnel to devote to that stuff, that's only gonna get better over the next year. So I'm hopeful that that's not on our challenge list in the future. But the investigation of unexpected field data is one that's going to be huge. So as we go through all these trends and things that we're looking at, just having the ability to look in the daily work reports, things like that, to figure out if something's unexpected happening, why is that happening? So that's something we'll be digging into more now that we have more personnel. So yeah, that's kind of what I have for what we've been working on and what we're working on in the future. Contact information, I'm sure you already have Tom's, but that's my information as well. So I'd be happy to talk to anyone about what our program is. So thank you very much.
Well, that was a great presentation. Thank you very much. So we have 9 minutes here, and that's good because we have a lot of really good questions to get through. Steve Cooper asked first, when you say joint cores, is that 6 inches off the joint?
I'm gonna lean on Tom a little bit because he was actively involved at the time we did these things. So we got both of us here.
So the sensor was 6 inches off. Yes, obviously we're cutting our core right. A lot of these, I believe, were wedge joints, so we were right along the wedge for the actual core, but the sensor was 6 inches off.
Okay, so that could explain some of the difference between what the DPS was predicting and what the core was showing. And
I should say some of the slides that Brendan shared really kind of highlighted some of the things that we're seeing, but we had other locations where everything lined up really, really close. There just seemed to be a little bit more variability when looking at all of the data from the joints relative to the
Yeah. And I think that was a really important thing to bring up because I know in our experience with the joints that we're experiencing with DPS here in Minnesota, we have seen inconsistency if we try to run it directly over the joint. But I know Rich Giesel has had success running it directly over the joint. So, you know, kind of digging into, is it a joint construction specific effect when it's inconsistent at the joint, or the kind of the details of a joint measurement, both from a where the core is taken perspective and where the validation or the accuracy check dielectric value is coming from, is pretty critical. And so right now, at least what we're recommending, just to play it safe, is to have both the core and the dielectric measurement at least 6 inches away from the joint, which is a little bit less ideal in the sense that the failure occurs first closer to the joint, but just to make sure we're not getting fictitious readings because of the geometry of the joint. That's what we're currently recommending. Rich Giesel followed up with, are you drilling the joint cores centered on the physical joint? Do you have vertical joints or notch wedge? And it sounded like, if I remember correctly, Tom, you said that it's a notch wedge joint?
Yeah.
Okay. Is there any follow-up there, Rich?
No, Kyle just said we do see a lot more variability when we run right on the joint, on the physical joint, and especially if it's a mill and fill where we have a vertical joint.
Yeah.
Which is what you'd expect, unless we have a joint heater that's warming that up and making it consistent. We do get a lot of variability, so it's a real variability when you're on the physical joint. It's not machine error. It's actually varies that much unless there's things done to make it consistent.
Mm-hmm.
You know, and the one thing I'll add, Rich, and I don't think we talked about this, but I believe those joint cores that Brendan shared were actually from our 30A project, which was also recycled. Cold in place recycling underneath the top, and there is a tendency sometimes for water to come up through that joint early on. That also could be adding to some of our variability that we're getting there.
Yeah, that would definitely do it.
Definitely. That's a good detail. Let's see. So yeah, Steve beat me to the question about the joint, so we don't have to address that one. Di asked, did you also compare core results with lab calibration results?
I believe, and actually Rich Hamilton, who's on the call right now, he should know. I don't know if we actually placed anything from our cores on our calibration curve. Rich, do you remember if we did that?
No, we did not.
Okay. So that'll be an interesting thing to see too, if you have any bias between your pucks and your field measurements, or if those are hitting spot on.
Yeah, we no, fair point. We should we can do that for you.
Awesome. Yeah, and then our next question is with regards to the personally, I thought that what you were doing in Excel there to visualize the by offset, what you're getting statistically is great, and it has a nice visual representation of it there for you. And Rebecca followed up on that, saying she would recommend using 150-foot sublots if possible to match up with the paver-mounted thermal profile method sublot sizes. The statistics per sublot can be calculated quickly in Veda per data sublot and the entire data lot. Additionally, you can visually map the data in Veda. Have you guys been working with Veda at all in New York?
We've used Veda for the IC work. We haven't done anything with the thermal bar yet. Not opposed to looking at it from a 150-foot perspective. And the other thing, I mean, so when we did this 100-foot lot for that visual kind of look through on this, you know, Brendan only showed 4 on there. You know, we had hundreds of these, and it's almost looking like an old school flip book where you can see where things are actually changing in every 100-foot block, and you can see how one lane may be acting a little bit differently than the other lane. And both of these on this project, the paving was matched up at the end of the day, so that brought a few more questions into us as well. one thing that Kyle, that I know we talked about with you, is that we also had some locations on this that were giving us greater than 100% density. And that was one of our questions of how we're going to handle that kind of data. It jumps off the page a lot more when you look at it with this kind of color graph. But it is a question of, what's going on right there, and how can we kind of get that information immediately to us to say, wait a minute, what's happening right now with our scan?
Yep. And to me, like we discussed, I think that's an indication that something either went wrong with a sensor or with the conversion from dielectric to density, or the conditions. If, for example, there's moisture on the surface, that'll jump up your dielectric and also your density. I see Rich Hamilton giving thumbs up on something. What was that about, Rich?
The variation I've observed in the cores largely has to do with water.
Okay.
Again, as Tom mentioned, we had quite a few recycled projects where that hot mix layer was wicking moisture up through the cold in place and then basically dribbling out of the joints as we're taking measurements. So
yeah,
you get high readings. It's probably water. The other thing we've seen is joint sealant has an effect. We had a couple projects, they're sealing the joints. I don't know what material they're using, but those numbers went sky high.
Yeah, and just the last thing to add on that, one thing we've observed just based on the joint geometry is actually an increase in apparent density if you're measuring on the side of the joint right over it where there's a lip. It has an amplification effect or something of that nature that's giving us a higher reading. And like I said, our solution at the moment isn't ideal, but it's to collect 6 inches away from the joint in those situations. But that's good feedback too, Rich, that water is the likely culprit for those situations. But that's something we got to handle with our spec. Rebecca also followed up with a nice map of how DPS, IC, and PMTP data can be mapped in Veda. So. Great presentation, guys, and you're doing a lot of projects, which is critical to get the feedback we need with the technology. So thank you. Moving on, we have Ohio DOT next. Craig Landefeld, if you want to take it away with sharing your screen.
All right, Kyle, let's get this going here. This will be the right one. All right, Kyle, does everything look good on your end? I lost it once I hit.
Yes, we see it. It's
right,
full
cool.
screen.
Okay, so this is just some of the updates from 2021 from Ohio. I got the first slide is 1 step forward and 2 steps back. We kind of thought that this year we were, past some of the COVID restrictions and things, so we were really ready to go. And then we ran into some staffing problems that kind of derailed our plans and forced us to, divert some of our staff that we were planning on using and doing some scanning with to some of our more core functions, and research was the first thing we had to drop. So unfortunately, we were only able to scan on 2 projects. One project, we got a lot of data, but we had some other issues there too, which is where I go into some of the contractor issues that we had this year. In that we had some contractors who, the first project that we did, that we'll talk about here in a minute, we had a lot of days of scanning, and they were to make gyratory specimens for us every day. And after hounding, I think we finally got like 2 days out of them. So it didn't really work out the way we had hoped. And it was something that was, more of a handshake thing. They were going to make the specimens for us, and I don't know why things went so sideways, but they did. So certainly 2021 wasn't what we'd hoped for. So hopefully 2022 we'll see some progress and get several projects collected and evaluate some of the things we're going to talk about today in a little bit further detail. So our collection procedures for 2021, some of the issues we'd seen in the past, we thought it was really important to do the air and metal calibration every day, even though the software in the machine wasn't requiring the metal plate. We did those daily, which will be important here in a minute because we're not sure what happened. We did AM and PM line tests for the vast majority of the project's collection days. We started off early on doing just one line test per day, and I think Kyle and I actually had talked not too long after we got started there, and we kind of chose to do an AM and a PM test. So we collected that data, which is kind of interesting. We continued with the swerve collection pattern. I think we'll probably end up revisiting that now that the Veda is now able to accept the data. I don't know that the swerve pattern's maybe going to be the best for that. We like that method of collection, but not sure that maybe it wouldn't be better to collect more linearly with the Veda software. We really focused on capturing all the acceptance cores, and this year we on this project we didn't actually go out and lay out cores as we had in the past with the high, medium, and low dielectric spectrum. We actually just collected where we were going to take our acceptance cores daily for the project, which would be 10 cores for the mat and then the joint cores. And that was kind of interesting. We'll see in a second. The lab gyratory samples, again, the contractor, made very few of those on the one project. The other project, we did get some lab samples, but we haven't had a chance to run them. They just got everything back to the office a few weeks ago and trying to get through that as we speak. As far as longitudinal joint collection, that was something we wanted to focus on this year as well. And we collected with the machines. We have two machines now, two of the new 2.0 systems. And we had one machine where we were straddling the joint, putting a sensor basically 6 inches on either side of the joint and trying to run a sensor down both sides. We also had a machine where we set up a sensor and ran it right over the physical joint. We'll look at a little bit of that here in a minute. So the first project was Coshocton 36, just some details about that. That's a 7-mile resurfacing project. It's rural 4-lane divided. It's 1.5 inches of 12.5 millimeter intermediate and 1.5 inches of 12.5 millimeter surface. We had hot joints on the shoulders, a cold joint at the lane line, which is where we're measuring the joint density. This had ODOT's 447 joint density spec on it, which is a PWL with physical cores, 6-inch cores centered on the joint. ODOT does ODOT uses a vertical butt joint for virtually all the projects that we do. Very rarely do we see wedge joints in Ohio, and most of the contractors to meet this joint density spec, this project included trim about 3 to 5 inches, 6 inches off of the unconfined edge before placing the confined pass and closing the joint up. One other thing that we do in Ohio is on this spec, we require a joint adhesive to be used on the joint. We'll talk about that as we go through. And then again, the contractor was supposed to make the gyratories for us, and that didn't happen. So this was the first thing where we're scratching our heads on the project, and we've seen some data from others that seems to show that the repeat test data is really really tight and really solid, and we keep running into days with the equipment where we can't get the repeat line tests to fall within the difference between sensors to fall within the ranges we'd be looking for that 08 range, and we're not really sure why. We troubleshot some things with GSSI as far as sensor heights and levels. One thing that was interesting too is the machine was constantly reading that the sensors were out of height adjustment, and when we would measure them, they were just slightly high, but there's no other way to adjust them. That's the way they came from the factory. We can't lower the bar anymore. So that had us scratching our head a little bit, but we looked for, you know, a certain sensor that was causing a problem. Everything seems very random. You know, we did see on this project, you know, machine 2 drop out a couple times, but then we had machine 1 that was out a couple days as well. And some of these we would even, you know, the technician would get the error on the screen when they ran the test, and they would just run it again and get good results. So, you know, we're wondering if there's some user error or what could be causing some of the issues that we've seen, and we've been trying to dig through the data a little bit more on that. So then things got even more interesting because we had just absolutely terrible core calibrations on this project, and this is the first time we've really experienced this, and again, it had us really scratching our heads. The method that we used was the contractor was, you know, given the core locations, you know, for the sublot as they've moved on. So the inspector would, you know, have the random numbers generated and know where the core location would be. They would mark them out. We would scan with both machines. We initially started doing one in time mode, one in distance mode, and then the technicians on site decided to switch it to actually doing both collections with both machines. So we got a fair amount of data with both of them, and scanned the cores both ways, but really got some just awful core calibrations when we brought it into the office and we're looking at it. Again, these weren't using any kind of targeted cores, but we did see, you know, densities that kind of span the, you know, the dielectric spectrum. So again, we were just kind of scratching our heads as to why we saw this. So this is machine 1 versus machine 2, both in time mode. We also collected them here in distance mode, which we got a lot more with machine 1, but still ended up with, you know, a fit coefficient that was just not very good. Again, scratching our heads. We really don't understand why that's happening. Was really hoping, and would have been nice to have had the gyratory samples to compare to some of this as well and see what we had going on there. So for this project, we also scanned the longitudinal joints, like I mentioned. We did the, you know, the straddle, as we called it, where we had a sensor on each side of the joint. We also had the sensor right over the joint. Unfortunately, with our core calibrations and things being so weak, and we didn't really think that we could just apply a calibration curve from the mat to the project and look at densities and see how the density actually panned out. But what we see here is we've got the dark blue and the light blue sensors from the 2 separate machines with the single pass, and then we've got up here the red with the M1 for the straddle, and we saw a reasonable comparison, but again, a definite shift from the from some of the data when we started doing the straddle versus the single lines, which really didn't surprise us a whole lot, you know, as we scanned, and these are us taking the average dielectric and plotting them for those scans. So these aren't targeted locations. This is, you know, several hundred feet where they've ran the joint, and we've averaged the dielectric across those, and we're planning to correlate it to density and compare the results we saw with that with some of the PWL evaluations from the joint cores that we saw. That didn't work out so well. We also did we got plotted here the two machines with the 2 sensors straddling, and you can kind of see the little bit of difference that we saw as we went down and you know, scanned both sides with 2 separate machines. So our second project went a lot better. This was a research project that we were working on with OMM, and our lab folks had a producer who has a plant called an Oman plant with capabilities of producing very high wrap mixes, and we were doing a research project with some of that material. So this project was 5 miles of rural 2-lane. It had a 1-inch intermediate course, a 1.25 inch surface course placed on top of it. Intermediate was more of a leveling. And then the control section was a type 1, ODOT type 1, which is a finer graded surface mix for a 2-lane. It's a Marshall mix with a 70-22 binder and 20% wrap. And then the high wrap was placed in the opposing lane for the test section. It was a balanced mix design mix. It had the type 1 surface, same gradations and requirements there, and binder, but this one used a 70-22 with recycling agent to meet the 70-22 final grade, and ran I think the actual mix design ran closer to 60% wrap for this project. So again, we took the machines out and saw some line test data that was a little bit concerning certain days and scans. We had both machines on the project for the 2 days, and then the rest of the time we were only able to free up one technician to get out there and run the mat. So the other days we just had the one piece of equipment out there. But again, we saw of the 7 days we scanned, we had multiple days where we were either slightly outside the tolerance and sometimes dramatically outside the tolerance when we were running the line tests. As far as core calibrations, this went much better. Again, these were more randomized cores on the project that we were using and collecting for the some of the research work that we were doing. In the control section, you can see the cores, and we got a 0.7 fit coefficient with that. Things look pretty reasonable and much more like what we'd expect. Maybe not quite as high as we've seen on some of our other projects, but we also weren't going out and targeting the high, medium, and low dielectric spectrums with these projects. Then over here we see kind of the density histogram that was developed for the project. We're just really kind of interested in the lab was wanting us to evaluate this. So as they go and look at performance of these sections down the road, that they could see whether there was something drastically different as far as the density and the control versus the high wrap that may explain maybe some of the different performance that we saw. So overall, mix look was placed very well for the control section, very much what we'd expect from densities out there. So we ran into the high wrap section, and again, pretty good fit coefficient, much more like our past experiences had been. Again, randomized cores though, nothing really targeted about these, and maybe not as so totally unexpected, but we saw a much broader density range when we ran the high wrap mixes. We'll see how that shakes out in the pass or in the performance in the future here, but we definitely saw a much broader density range and lower average densities on the high wrap section. So for some the gyratory results, we're hoping to get to those soon. I must have got a slide messed up here, but yeah, we're hoping to get some gyratory results in here soon. We collected gyratory samples on those, and again, we had them in the lab the other day, and we've got all the dielectrics run on them, but haven't had a chance to actually get the specimens weighed up and see how they compare on the control and the test section to the cores that we got out there. So really interested in getting that wrapped up and see what happens there. One other interesting thing that we found though, and we had in last year when we presented some of our data, we had some sensor errors with a temperature input in one of the sensors, and we noticed that when we started seeing these shifts when we tried to compare the two machines. And so we got all that stuff corrected, and this year we've seen much better comparison when we look at, you know, machine 1 versus machine 2 and take all of our data and put it together. You know, some of our questions still are things like, you know, what is a good comparison, and, you know, how should we look at some of this data when, you know, trying to do a quality assurance versus quality control, you know, an acceptance type of you know, method for us. ODOT coming in and scanning with another piece of equipment and trying to do quality assurance or acceptance. So we saw pretty good comparisons here, but again, some of the line tests and things were not as tight as what we would have liked to seen the data. So we're still digging into some of these, and it's concerning, but you know, definitely watch some of these things in 2022 and try to wrap our heads around that a little bit more as we get going there. So just a few things to consider. We're kind of scratching our heads as what's causing some of the sensor variability that we see. It seems very random, and Kyle had mentioned some things yesterday in his presentation that got me thinking a little bit. So I'm going to investigate those. You know, some of the causes of these poor core calibrations. This is really the first time we've experienced that, and we're not sure what happened there. How do we define comparison? And unfortunately, I missed some of the presentations yesterday, but I want to go back and look at those, because I know that's something we're looking at here with the pooled fund and some of the other participants. But yeah, that's one thing that we've been kicking around a lot internally is, you know, how are we going to define what we mean by compare, and how close you know, should we reasonably expect things to be tolerance-wise when we say they compare? When we talk about the joints, the joint enrichment, we call it, we actually coat the faces of all of our joints before we close them up. And so we're wondering what kind of effect that is or could have on some of the data that we're seeing. So that's something we're definitely going to be interested in looking into a little bit more in 2022 and see what impact that may have on what we can scan with the joints. We've also been using, we call it void reducing asphalt membrane. Some of you maybe have heard it more as J-band from Asphalt Materials. There's a few other suppliers out there. We've been using that on a significant amount of projects over the last probably 5-6 years, and we've got a little ongoing research project evaluating their performance. So that's another thing that we want to look at with the tool and see if we can use that to help us, you know, assess what's going on there at the joint. You know, we know we can't measure directly density because we've changed the material makeup so much, but wondering if maybe we can use that as a consistency tool or something there. So what's next? Again, we're still trying to get these machine comparisons worked out, and I think that's going to be a big key for Ohio, because we're definitely going to, in order to implement something like this, we're definitely going to need to use contractor data. So we're going to have to find a way to do the acceptance testing from the department and make comparisons to accept contractor data. Gyratory procedures in 2022, we'd really like to sell a project or multiple projects actually, where we actually require the gyratories to be done on the contract. So we have a little bit more hammer over the contractors to actually give us the data that we're looking for. Again, we're going to look at the SWIRP versus the linear collection. I think with VEDA, that's going to be very important. Longitudinal joints, you know, again, continuing to collect more of those and you know, start to evaluate things from that perspective and see how we can deal with longitudinal joints and what might be the best method there. From a VEDA analysis standpoint, that's something we're really interested in. We were really glad to see that get module get added into the latest software upgrades, and so we're really excited to do some analysis with Veda in 2022. And we've actually got a contractor who purchased one of the DPS units. They've got a single sensor, so we're kind of hoping that maybe we can get a project with that contractor, and they also have some of the IR technologies, and try to bundle some of this stuff up to see what we can really do with it. And from all that, we'd really like to get some specs together with a goal of trying to, sell a pilot or shadow project here in the relatively near future. We had hoped that, by the end of 2022, that we would be, ready to sell a project where we actually do a shadow and try to require the contractor to collect data and see if we can, make this work from a real world standpoint. But I'm not sure if we're going to quite get there or not, but we're definitely going to head down that path and try to get some of these specs together to do that. So with that, I think that's all I had. So Kyle, I don't know if you got any questions or not.
Yeah, we did. Mostly for me. I thought it was a great presentation as always, and I think one thing to note that I like that Craig does, as well as the other presenters, is sharing those hiccups along the road too, with the consistency issues. And there's some questions I had in there that I think we can save until later, just to keep on track. And the other thing I wanted to mention is part of the funds that we have available to do through the pooled fund to do data collection for the next construction season might be useful if you need help funding wise to get the contractor funded to do the gyratory test. So maybe just follow up with me afterward to see if there's something contracting wise through the pooled fund that would be helpful there, because I think that data is critical as we're developing the spec to get from multiple states and all that kind of thing. So
yeah, and with us, I really don't think it was a funding issue.
Okay.
I think it was just really a communications issue. I think they had a guy who was in their farther up their hierarchy there saying, oh yeah, we'll do that, and getting that communicated down to the guys who actually had to do the work was not happening and fell apart. But if we put it in as a contract requirement, I'm confident that we can get to do it. But yeah, that's something that I think we really need to work through. And
just let us know if there's anything we can do to help with the contracting portion of it and spec and all that. So yeah, great work as always. Thanks a lot, Craig. And the other thing in the chat, other than my questions, was Richard Hamilton from New York had said there's height adjustments of the sensor mount bar by adjusting the Allen screw in between the bar segments. So they had to do that a couple times.
Yeah, and Alan, ours are spot on. I mean, we had our technician go through before we started this year, and I mean, we checked every single sensor. They are level. They are right, and that's what is making us scratch our head so much, because that was the first thing that GSSI had brought up to us. So.
Yeah, and I think we should be able to also help look at some of that data too, if that's something you'd be interested in. But again, we can follow up after the meeting on that. So
yeah, I think that would probably be a good idea, because again, we've been kind of rushing here to get through some of this stuff to get some information ready to share, and so we haven't had a chance to really dive into it, but we're definitely going to have to do that. So
awesome. Well, thanks a lot, Craig. With that, I think we'll move on to North Dakota. And I see John is already on here sharing his video, and then you know how to share your screen in Teams. Got it.
Everything works?
Perfect. That's some shiny asphalt you got there.
Yeah, we'll get to that. But good morning. My name is John Stork. I am a research engineer in our materials and research division here at the North Dakota DOT. I've been one of the primary operators for the DPS system implementation here in North Dakota. I'll try to be brief on a lot of these, because a lot of them have already been covered in great detail in previous presentations by people that are much smarter than I am. So we'll get into it. So we North Dakota became involved in the DPS world back in 2019 when Kyle was gracious enough to come over and to allow us to demo their equipment on a job on the eastern part of our state. I think he actually came out a few times due to some rain delays. Through these demos, it basically piqued some interest in our controlling factors in our agency to where we were able to get the funding to procure the GSSI RDM 2.0. Since we have joined this pooled fund back in 2020, we have now been doing data collection for the past 2 construction seasons. Just a little bit of background on our paving processes. The way we traditionally do things is we take a set of core measurements per sublot, which in our case is 2,000 feet. Obviously, that leaves a substantial margin of error for density anomalies between the coring locations. So we found that the DPS seems to fill that void for uniformities. We typically collect in a similar fashion to the way MnDOT does, where we only have 1 unit, but we collect in a 3-pass system with varying sensor widths depending on our roadway width. We've been using the repeat line test both transversely and longitudinally. We've been doing intermittent swerve tests. Since we've used beta, we've kind of dropped that off a little bit. And then we've also been using HDP anytime we shut off our machine. We typically collect in a partial closure with a pilot car. So safety is one of our biggest concerns with that. The key is to find the sweet spot where you're not crowding the finish roller, but you're also close enough to the paving operation that the pilot car doesn't try to hop in front of you to get out of the way of the asphalt and bring live traffic to you. So that's been a little bit of a challenge. So what have we done since we've joined? To date, we've collected 6 different projects across the state, 7 if you include the one that Kyle came out and collected for us on the east side. All of our collection is done internally through our section, so it's not something that we contract out. That's obviously a big challenge for us. We try to vary our locations across the state just so we can get different project staff and district staff to come out and actually demo it to see some of the benefits of it. Because ultimately we'd like to be able to push this out to our district staff to have them do some of the collection or to contract it out accordingly. So you can see the breakdown of the locations and the type of mixes. Of these 6 projects, 5 of them had other aspects of intelligent construction on them, which is partially why they were selected. 4 of them were recycled asphalt, had some percentage within them. We typically use more wrap mixes than we do virgin mixes. So we're trying to focus mostly on similar mixes just to try and avoid some of the variability. As Kyle has mentioned before, a lot of it comes from the aggregate sourcing. So that's kind of a wash when we're talking about getting aggregates from different sources. But a lot of the project selection comes from the staff availability. Like I said, we run it out of our central location here in Bismarck, and we have a fairly small research section, and we do all of the collection. So that's probably been our biggest hurdle, and then also just the timing of these projects of when they actually go. So last construction season, we were able to collect approximately 50 miles of single pass collection. We also received the lab kit back in the winter of 2020. So we were able to do a lot of the laboratory specimen and the calibration curve correlation to predict density values. So we focused a lot on that this summer. I also wanted to point out, and Leslie mentioned this yesterday, but the Matsy trailer also came and visited us here on US 83 up north. So we are definitely very grateful that they had the opportunity, or we had the opportunity for them to come out. And we appreciate the work that they did for us while they were out here, and also the work they're continuing to do in the lab. So Kyle kind of touched on this already with his laboratory gyratory relationships. We follow a similar process where we take multiple dielectric measurements on low, medium, and high gyratory plugs, or you guys call them pucks, and then we compare we basically overlay our field cores after they're extracted the next day and bulked, And we've basically been comparing the results of how they overlay into our data set. It allows us obviously to not have to find the 86% in our mat, which we try not to have. So it's great to fill out and populate those curves. Another thing that we wanted to investigate was the sensitivity to normal production mix changes. So we've been doing some morning and afternoon testing as we undergo certain production mix changes. So what we're seeing here was an AM test, and then they made some changes that you can see here on the right. So a slight normal increase to your asphalt binder. It actually shifted our curve up about a 1.5% at a similar dielectric. So we're working to look kind of to figure out what's a reasonable testing frequency, what triggers a retest, what of these mixed parameters actually make us retest. Or like Kyle said, you can get another standalone unit that you have in the laboratory and you test production gyratories to catch those changes throughout production. So that's just another thing that would be great for us, is to have the manufacturer sort of do a standalone system that doesn't require us taking our part to the laboratory to measure these before they're bulked. We also wanted to know similarly how these calibration curves track from day to day. So we have done some testing in consecutive days and also in consecutive weeks to see just how they track within a range during the normal production mix changes. Typically, we found pretty good accuracies. Usually it's 1 to 2% variation at similar dielectrics. That's what we're showing here. This is up on the FHWA job. One of the most important factors for the implementation of a technology like this is the ability to accurately predict the density values, obviously. So these are the days we basically looked at all of the days that we had enough data and enough coring and enough lab work to where we could create a trend between them. So what you're seeing here is the core values average, and then what we predicted them with the coring after they were extracted. And then this is if we went to a coreless method. The uncorrected is if we went strictly off of the laboratory specimen calibration curve and then predicted. So this is your absolute value deviation from the actual core value. Similarly to what some other NCAT, I believe, alluded to, is when you get below 2 inches, we've found a decrease in accuracy and an increase in variability with our predicted accuracies because of the underlying layers. Obviously, the biggest factor in the deviation for some of this stuff is the variability in the production mix. And while some error is inherent, when we're trying to fit basically an entire day's worth of coring results to a single curve based off of a single sample on a production, we're hoping that through the use of percent within limits and other intelligent construction technologies, we'll be able to sort of tighten these up so that we can, at least reduce the amount of production coring that we have to do. So this actually kind of came up in the chat a little bit ago, but intelligent construction and the use of Veda 0.7 or of 7.0. We've been using Veda for intelligent construction for a while, just as a deliverable from the contractors, but with the implementation of 7.0, it's really been a nice addition to be able to input your dielectric values and then also your predicted density values here, and then forensically be able to compare them to your other aspects of intelligent construction. So traditionally before this, you'd have your coring results or your nuclear tests. If you had like a paver stop or a cold spot, you'd have to pop a core. Now, because everything has GPS based, we can go in after the fact and analyze the construction aspects and their effect on our compaction values. And then this was also alluded to in previous presentations, but one of the biggest hurdles is the immense amount of data that is outputted by collecting projects like this. So before this, we were doing basically just slews of graphs and spreadsheets and KML files, and we were crashing Google Earth all the time trying to represent visually all of this stuff. And so Veda 7.0 has been great for just bringing all of these aspects together. You have some of the analytical tools, and then also just being able to show the benefits that are associated with this technology. So my only complaint about this Veda is it's not the most user-friendly if you've never used it before. So it's not really one of those things you can send out to your project staff with limited training and say, hey, just go ahead and create a Veda project. There is a learning curve to it. Kyle has already sort of pointed out some of these. There's some walkthroughs and other things that are great tools to help you overcome that learning curve. So definitely take advantage of that if you're going to pursue Veda. And I think there's a lot of great tools in this, and that's probably where the future of analytics for DPS data will shift to. So some of the things we've learned through our collection, these seem like common sense. If you haven't dove into the deep end of data collection, number one, get a spare set of batteries. It's about $400 for a set, and I know that's pretty steep for 2 batteries, but it's absolutely worth avoiding the downtime. We used to, when we were running one set, we'd basically make it a little bit after lunch, and then we'd have to sit and let our batteries charge and sort of limp along the rest of the day. So definitely having a second set that's fully charged. We actually run a solar battery bank for our GPS as well, just to keep that topped off, and that's worked really nice for some of those 12 to 14-hour summer days when we're collecting. And then 2, upgrade your GPS, because the stock unit that we've had from GSSI just isn't quite accurate enough for some of the precision work that we've been trying to do. So they boast basically a 10-foot, 95% of the time you're going to be within a 10-foot accuracy, which if you're looking at, using your vehicle, how to get to McDonald's, that's adequate. But when we're talking about comparative passing or doing core locations, all of that to, adjacent passes, all of this is not quite precision geared enough. So I would definitely budget for an upgrade to the GPS if you look at implementing the DPS. So what you're seeing here is actually a pre and post fog pass, which we'll get a little bit into that. Essentially, it's running on the same alignment. You can see the first one is along the longitudinal, right, actually inside of the longitudinal joint. And then we came back after they fogged it about an hour later, and it put us into the adjacent lane. So that's something post-processing wise we've been struggling with. You kind of have to manually shift them over either through Veda or just through, an Excel shift when you want to do comparisons between multiple passes on the same route. So fog seal, I guess I don't really know the effect of this on other states and agencies and people. Seems like MnDOT never uses it. GSSI hadn't really seen it. It's something we use pretty significantly. 5 of our 8 districts use it. Maybe you guys can put it in the chat if anybody else uses fog seal to seal your surfaces, or if we're unique in that. But anyway, we use it. Obviously, it's a surface applied, so we wanted to see the impact that it would have on our dielectric readings. So we've done a lot of collection pre and post fog, where basically we do static collection or we do corridor along the same alignment and then compare our results between. We've been able to come to some conclusions. We're going to continue doing some of this because it is a big issue in North Dakota. So we're basically hoping that it would be a non-issue once the water evaporated and left behind the residual asphalt. We've been finding that it's basically a 0.05 to a 0.2 increase in dielectric after the fog. So anywhere between a 0.5 to a 2% increase if you collect after the fog. We were hoping it would be somewhat consistent, so maybe we could collect after and then subtract it out. But that hasn't been very lucrative, just because of we found some variability in the shot rate and then the coverage. So you can see here on the photo, you get some areas where they have, maybe a full nozzle spray, and then you have some areas that have less of a coverage, whether that's the wind or the equipment, or the lane width, all of that. Depending on where your sensor falls along that route, it can vary your dielectric increases pretty significantly. So that's been something we've been fighting with. And then also, if we do collect pre-fog, we basically impart additional process delays for the pilot car operation. It's one of those things where if we're in between the tack truck and the finish roller, the mat is now cooling, and so when they apply their fog seal, it takes a little bit longer to evaporate. It sort of draws out your traffic control distances as you get into the evenings, and then later in season it's a little bit colder. It takes a little bit longer to break, and it's definitely been a little bit of a headache dealing with that for us. So if you do have questions on fog seal, I'm happy to reach out, or you can reach out and we can talk through it. But similar to other states, we've been having issues with longitudinal joints. We have tried to do collection over the actual joint. We've found issues with, obviously, whether it's just the butt joint itself, or we double tack our joints, our vertical faces. So I don't know if it's the residual oil that's causing some issues with that, or if it's just the geometry of the actual joint itself, or if it's the opposing grades. But we haven't had a good correlation when we're actually running above the actual joint. So we too have been running basically 6 inches inside of the joint, and considering that our joint pass, we were hoping that we would be able to run ideally over the joint so we could eliminate or at least verify the longitudinal coring that we do, because we do core at the interface of the 2 lifts or of the adjacent lanes when we use a butt joint. And then when we use our notch wedge, we've also had some issues when you're collecting 6 inches over here. You're a foot basically away from where you're coring, and when you're collecting 6 inches here, you're actually getting some of the tack at the inner layer on your notch wedge itself. So we've had not the best correlation when we're trying to do longitudinal joints. So definitely a struggle similar to other states, and we're trying to work through that. So just some final thoughts on this. Uniformity is one of the key things that we've had takeaway wise. The ability to confidently say when you're out there collecting that this segment here is the same as half a mile back, even if you don't have actual density correlations and you're just running dielectric. That's a very powerful tool for construction aspects of it. 2 is the consistent hot mix production. After the first day, once they've sort of dialed in their mixes, we've had pretty consistent ability to predict the dielectric to density conversions. And we feel that as we implement sort of the percent within limits and the other intelligent construction technologies, we can actually tighten that up a little bit more. We are hoping sometime in the next year or 2 to be able to pursue, a mock shadow acceptance where we basically run the entire length of the project and then compare our conventional acceptance density coring versus what we would get if we use the DPS's full acceptance. So one of the big staffing problems, or one of the big problems with DPS has been our staffing. Like I said, we run it all internally. So we've been able to collect 3 to 4 days typically per project. So to get the entire staffing workload to collect a full 2-3 week paving project, that's something that if you're looking to pursue some of this stuff, be ready for the staffing and the financial implications associated with that. You'll have to dedicate full crews to full days of collection, and also to full weeks for project collection. So I will say that MnDOT and looks like New York and Ohio, they with the contracting out, we haven't taken that step yet. I'm hoping we're going to go that route. We just haven't financially committed to it yet, but that seems to be a good route to take. So I would say my final point is, for those of you that haven't gotten out and actually done it, go out on a project and try it. I think FHWA's loaner program is pretty awesome, that you can actually get out there and use it without actually having to overcome the financial side of it. The collection itself is fairly easy. I would say the lab side, and there's plenty of resources out there. MnDOT's done a great job of running through all of that with the videos and everything else. And I think that's one of the major benefits of being a part of a pooled fund study like this, where you can do some of this knowledge sharing. So definitely capitalize on stuff like that. Contact information there. Feel free to reach out if you have questions for me. If I will do my best to answer them or point you in the direction of who could. Do we have any questions? I seem to have lost my chat.
Well, first of all, great job, John. You guys have done a lot of work this construction season, especially not contracting anything out. You've been busy.
Yes, we have. Thank you.
So, we have 3 minutes until we get to the round robin with the remaining states. And again, much like with Craig, if financially it's an issue contracting out and you want to try to see how that would work, there's a potential we would be able to support it through the pooled fund. So again, just email or talk to me afterwards. Just out of curiosity, or either you or Amy, do you have an idea on who, if you did get this to deployment, who would be doing the data collection for you guys? Would it be a contractor or agency, or it's too hard to say at this point?
Yeah, don't know.
Okay. Okay, and we did have both Craig and Rich responded about you were asking questions on if people are using fog sealant. Craig said we tried several sealers and fog seals, but the skid numbers always tank for a few weeks, and it wasn't enough performance improvements to justify their use. So there's your solution. Just don't do them.
We don't. That's a topic for another. We don't have.
Yeah. Yeah. And then Rich said ASTM D2995 is a good method to get your TAC application more consistent. I recently wrote a test method for this. Yeah, thanks for that, Rich. So, and then if anybody else has a question that's not in the chat, feel free to speak up. And then also, if you use fog sealant in your states or not, if you could indicate in the chat. I think that is a good question that John brought to the group. One question I had, you showed one slide that had a fairly significant change between AM and PM for the calibration. That's a really good data set to have. And if you don't have to, if you don't remember right now, that's fine. But if we could just follow up and just discuss what changes in mixes are causing those shifts, that's really critical information. So the more you have related to that, the better it'll help. So
yeah, we've been trying to track that, but you know how difficult that is to pin what's causing it, and that's been a big hurdle for us.
Yep, and we're going to be creating kind of a master database using our test summary sheets and mixed design reports and stuff. So whatever you can do on your end to add to that, I think it'll be helpful if we see approximately what changes stuff dielectrically. And we have an idea, like you said, that it's the aggregate source for the most part, but yeah, any information you can follow up with that is great.
Sure.
And then the other one, if there's no other questions from other people, is do you remember what was under that 1.5 inch thick lift that was showing that 1.49 deviation?
That was a cold in place recycling job.
Okay. Okay. Just another good thing to note. Okay.
Hey, Kyle. Just
yeah, go ahead, Steve.
More why they require a fog seal. It seems I'm not from, here again, I'm from the Northeast, but I'm not really up to speed why they require that at the end of construction. Rich Kiesel, when he was playing around with specs to promote DPS, he was also looking at, if there are areas that are not meeting density, he might require those areas to get a fog seal, but I was just wanting to hear more from John.
So that's kind of a district elected thing. Like I said, 5 of 8 of them actually elect to do it. Some are a little bit more lenient than others, depending on the mix and the amount of oil in the production mix. We do require it on a few things, like after rumbling, or if they have a low area of density compaction on like the longitudinal joints. Some districts are very adamant about using it, and it all sort of stemmed from when we switched from Marshall to Superpave. We sort of had a lot drier mixes. A lot of them started adopting that. Contractors were sort of pushing it a little bit. Some districts have done some research. Essentially the idea of it is where you have higher surface voids, and it essentially is a cheap insurance policy where you can seal up the surface voids and some of your absorbative aggregates can sort of absorb some of that and theoretically increase your impermeability there. But we've had some districts that have done some research on it where it was inconclusive on whether or not it had a positive impact, but it's sort of something we've been wrestling with for a while. Skid resistance and friction values are one of our negative aspects, but like was said, it sort of rebounds after the traffic and definitely after the first time a plow hits it. So
And Ken Swedeen has his hand up too. Maybe he has something to add on that.
go ahead, Ken.
Yeah, thanks, John. Great work, and I know you've walked a lot of miles this last summer.
Yeah.
And Bryce will, I think, be on later as well, and he's walked a lot of miles. But anyway, to address two of the issues, I guess, the fog seal pretty much has evolved over time, and a lot of times it might be 2 or 3 years from a pavement preservation standpoint before the chip seal goes down. And North Dakota's been using, typically the wrap percentages are between 15 and 25%. And if you looked at the spectrum in SuperPave between durability and stability, the needles kind of pointed to the stability end. And so a lot of those mixes using 75 gyrations on a 20% wrap mix have tended to produce what I would call dry mixes. So the fog seals were kind of a self-defense mechanism to both buy time to the chip seal, but also ensure that time that you weren't suffering any extensive damage before the chip seal went down. So that's where that came from. North Dakota's doing a lot of work with balanced mix design and performance testing, and I suspect it'll disappear with balanced mix design provisions. The second thing is, I was out on that project on the AM/PM, as John mentioned, the difference. One thing to consider is this job, it was about a 45 to 50 mile wet haul, meaning that it was about an hour delivery time from the plant to the paver. And there were times where there was, and this was also an IC job as well as a paver mounted thermal profiler. So there were some extended paver stops that could have played into it. And the material itself is a fairly common aggregate used in eastern North Dakota. And it was the moisture content in the stockpiles. And I think John mentioned this on a slide, that from AM to PM, the moisture content of the composite aggregate material had jumped up 0.8%. And I can't remember the exact value where it started with that day, but it was probably in the 4% range. So with that long of a haul, sometimes as your moisture content jumps up, and of course, if you don't get all the moisture out of the mix, it's coming out during the haul. And so there might have been more water condensation occurring with each drop. And I suspect, I don't know for sure, but it would be interesting to see if that could come into play, because from a mix design standpoint, there wasn't any significant change in wrap percentage or bin splits on the virgin aggregate. And as John showed in the slide, there was an adjustment in asphalt content to zero in on the 4% air voids, but that was the only significant change. So I would just add that to the discussion.
That's great stuff, Ken. I think you just signed yourself up for the technical working group, though. Sorry to break the news to you, but I think we need you for that. That's a lot of good information. And, you know, depending on what you're tracking, especially with the moisture content, that data is going to be critical for us to figure out what's causing the shifts in the relationship. So great presentation, John. Thank you very much. With that, I gave you a warning, and we're going to get into some of the updates from the various states. And you don't necessarily need to give an update if you don't feel comfortable. It'd be nice to hear what you like about the way the pool fund is going, what you'd like to see different, what you don't like. Anything you want to share is useful to the group. So I'm just going to work my way down the list I have here. And Idaho DOT, is Craig or anybody from Idaho DOT available to share anything?
Yes, I'm Craig with the Idaho DOT. We've been using the pave scan now for, I believe, 2 years. We have a consultant on board who's been collecting data, and they're finishing up a final report for us here. We should be getting that here in the next few days. So far, the data has been looking really good, strong correlation, good calibration. That's been working out really well for us. And then we're also going to be looking at putting together a training program so we can train others within the state to use it as well.
Who within the state, the various districts, or do you know what type of personnel you're looking to train in?
Yeah, we'll primarily try to train our own staff, but we'll probably bring in a few consultant staff as well.
Yes, of course. Okay, that's great information. And if I remember correctly, I think I had discussed with your consultant, they had taken some cores and then run the density on more than one lift, and they were going to test to see just the top lift, because we explained that the DPS only measures the top lift. So hopefully you guys got that figured out.
Yes. Yep.
Yeah. All right. Well, thanks a lot for the update, Craig. Rick Bradbury, Maine DOT, is always good for some good information, and Ulrich too, of course. So either of you guys, if you want to share where you're at Maine.
Rick is on the call. I don't know if Rick is on the call, but I can share quickly what we did, and Rick, if Rick has something to add, I will. I can share my screen as well.
Perfect, please.
Okay, so as many states already stated, we have so many issues with collecting data this year. Can you?
It's the upper right next to the red button. There's an up arrow.
Can you see my screen?
I can't.
Oh. Whatever.
If you go up to the upper right portion of the meeting, there's the red leave button. Right next to it, there's an up arrow. If you press that,
yes, I click on that. Yes, okay.
And then click on your whatever screen you want to share after that.
Can you see my screen now?
Not yet. You might need to click one more button. That's gotten me in the past, where once you click that up arrow, then it's going to ask, do you want to share a specific application or a screen?
Okay. Okay, anyway, can you see my screen now?
Yes, it's coming.
But it's not the right one I wanted to share.
Yeah.
Can you see?
GPR findings it shows right now. Main 2021 DPS GPR data.
Okay, so you can see my screen, right?
Yeah.
Okay, so we collected only 2 projects this year, and just roughly less than a mile for each of them. We started collecting DPS data since, I believe, 2017, and in 2018 and 2019 we collect more data, maybe 4 or 5 projects. But since 2020 and this year, we just collected 2 projects and not much lengths. And the 2 projects we collected were one was the rubber mix projects on I-295. It was a 12.5 millimeter water mix asphalts and 1.75 inch million field. It was a network. And the other project was 9.5 millimeters mix HMA, 1 inch a quarter overlay, and that was a day work. And as you can see, this is the network. the black dot, the black lane was on 1 foot away for the joints, which show that it's lower. We have lower dielectric, and we have noticed that for years now we have lower dielectric when we are close to the joints, either the centerline joint or the shoulder. But overall, we have more consistent value where we are within the lane, center line, in the middle of the lane, or 5 or 9 foot away from the joints. And what we notice here is that right on the middle of the lane, we have the higher dielectric value, which means that the compaction patterns seems to be more consistent, or more they are more in the center of the lane and where instead of where around the joints. This is the second this is the second project. It's less uniform than the previous one, but what we found out is we have higher dielectric value and lower standard deviation for each lane, and it was pretty interesting to see that. We collected two days for the same project, and with several offsets, and you can see it's almost all over the map, from 0.5 from the joint up to 11 foot from the joint, which is close to the shoulder. And yes, we were able to we used to show to do a contour map to see how consistent each line we collected is, and sometimes we try to overlay that with paver scan, the PVIR, the thermal profile data, and we try to align that with where we have some stop in the paver stop. And so you can see usually when we have a stop, we have lower dielectric value. And one of the biggest challenge was to be able to overlay the exact location of the paver stop and the dielectric lowest value, because of our GPS, the GPS we are using for our system are not accurate enough. Okay, this is a zoom in for the same projects. Okay.
Ulrich,
yeah.
It's showing instead of the full screen, it's showing your conclusions screen right now, GPR finding.
Oh.
So we're not seeing the. Thanks, Jacob, for sharing that.
Can you see my screen now? No. No.
Do you have two screens? If you go to your other screen, maybe you could.
Yes, I see what's going on.
Yeah.
I will share that. Let me share again. I see what happened. Sorry for the messed up.
No, it's okay.
That is not what I want. Yeah.
It's okay.
I know what is going on. Yep. Yes. You should be able to see the.
Yes.
Okay, can you see my screen now?
Yeah, it's a series of histograms.
Yeah.
At different offsets.
So that is what I was. Yeah. So this was the second project, and this was the first project. You can see for the first project, except for the centerline joint and the middle lane, which is 5 foot offsets, all other line were almost consistent or uniform. But what is surprising is that the standard deviation was higher for that project, even though the the electric was lower. But for the day work projects, we have higher dielectric and lower standard deviation. So that was something really interesting to I will go right to the what we found this year regarding the PERC calibration. Since we started this the electric collection, we never were able to get some good PERC calibration data. And this year we were able to accomplish that. And what we found was that where we used to do our lab measurement, it's probably because of a radio interference in that room. And as you can see here, this was the rubber mist project calibration we did in that room. And you can see the data for the same density air void. For the same air void, we have two different dielectric value. But when we switch from that room and we went to another room in another series, another lab, we found a more consistent calibration. And the blue dot is the blue line is for the 62 millimeter PERC. And what we can notice there is that it seems that the 115 millimeter PERC is more accurate than the 62 millimeter PERC. So we noticed we have two main conclusions here. One is that the first room where we were doing the calibration since we started this project, it seems that there is radio interference. What we want to confirm with maybe next year project, we might probably confirm that. And the 115 millimeter PERC seems to be more accurate, giving more accurate data. We collect a few cars. We were not able to collect more cars this year, and because staffing issue, other states already talk about, and we haven't find any correlation between the car calibration and the PERC calibration yet. Okay, this is a summary of our finding for this year. As I said, the rubber mix projects, we have lower dielectric but higher standard deviation versus the 9.5 millimeter standard mix, which has a higher dielectric means and a lower standard deviation, which suggests that we have a more uniform compaction pattern for the second projects. And for the second projects, we have only one knockdown roller. Whereas for the first project, we have two knockdown roller that were compacting side by sides. I don't know if that has, maybe one were compacting more efficiently than the other one. Yes, we already said that we have a lower values at the joints, close to the joints instead of within the lane. And yes, the PERC calibration doesn't seem to align with the field dielectric data. And we can also indicate that the pivot stop location are usually align with the low dielectric value. What we want to achieve next year will be to try to confirm that the radio signal on the rubber mix PERC calibration is one of the reasons why we were not able to have a good calibration data PERC calibration since we start this DPS data collection. And we want to confirm also that what the 115 millimeter thickness PERC is the way to go compared to the 62 millimeters, and try to establish a correlation between the core calibration and the PERC calibration. And I already talked about this before. Try to find the minimum pavement thickness that allow us or to guarantee us to have valid dielectric data in the field. And then use the RDM survey, which is the DPS survey, in conjunction with other new technologies such as the PEV-IR, the thermal profile and data. So that is all we did this year. I don't, let me stop sharing my screen. We hope to collect more data next year, but we have the limited resource for data collection and lab testing during the paving season, construction season. It's hard to make people work on our loose mix we collect in the field for bug calibration. So we are struggling with the staffing, but we rely only on the NDT crew we have here, and there are only 3 people, and they are working on other stuff, and it's really hard, and especially when we change when we have a program to go on the project and there is a change in the plan, it blow everything away, and so it's really a struggle to be able to collect some data. So that's all I have for as update for Maine. Hopefully we will be able to have more data next year and work on. I don't know if Rick is on the call. He can, if he has more to add.
It's a very good update, Ulrich. Thank you very much. I had a question about what you're using for your thickness measurement, but I think we'll save it for later to try to make sure we get to all the states. But thank you for that update, Ulrich. That's very nice. The Maryland DOT is Chandra or anybody from Maryland available?
Yeah, this is Larry from Maryland.
Okay.
Nothing super noteworthy to report. We just got fully staffed after a 1.5 year hiring freeze. I think that's probably where a lot of people are at from the way it sounds.
Yeah.
We did manage to get out to at least one day on 10 separate projects though this year. So we feel pretty comfortable with the technology, and so far very confident in the data we are collecting. This year was mostly about getting contractors more familiar with the idea and playing around with calibration from the lab and where to test joint density. Maryland has a history of being very joint focused, so I can see that being a key focus moving forward with this as well.
And you own one piece of equipment?
Well, just one, yes.
Okay, very good. Thank you very much, Larry. Mississippi DOT, is Earl or anybody else on the call? How about Missouri? Jonathan or anybody else have anything you'd like to share?
Yeah, this is Jonathan with the Missouri DOT. We got a piece of equipment we're borrowing from the FHWA, and it would help to get familiar with the equipment, but as far as looking at what the other states have done, we're nowhere near as far along. And it's just the learning curve, and staffing devote to this. But a couple of the big takeaways is taking measurements at night is a trick, particularly if you have no lighting. Another thing is we have temporary pavement markers they'll put out. They're kind of plastic things they'll put out to mark the lanes right after paving. And if you run over those, it will throw off your measurements, because it's kind of like I think it's plastic of some sort. So it's like running over the puck. So that will throw off measurements. And just the sensor calibrations, we would run the line and swerve test. We were having issues with sensors coming in and out of that. So it's kind of it'd be good to see that side of it get a little better polished, if that makes sense, the troubleshooting for the end user, because it doesn't, once you're out there, there doesn't seem much you can do with that.
Very good. Well, thank you for the update. Pennsylvania DOT, is Neil or anybody else available or want to share anything?
Yeah, it's not. I'm about kind of like Maryland, a little bit, but we're even worse than that, because as far as people to actually do this work.
Yeah.
We simply don't have a group to do this type of thing. We were kind of looking at trying to borrow a piece of equipment from FHWA, but again, we don't even have people to do that. The post-processing. So we kind of took a hard look at this here in the last few weeks, and we're probably not going to continue in the pooled fund, but you know, we like what you're doing, but you know, near or even midterm, any kind of implementation is just not going to happen. So,
gotcha.
Hard look at it. We're not going to really continue, but you know, watching your work, it's pretty cool stuff. So.
Well, you can still follow along even after you're done
will.
with the pooled fund, and eventually you'll get people and you'll implement it too.
Yep.
So thank you very much for the update, though. Utah DOT, Ken or anybody else have anything to share?
Yeah, Kyle, this is Ken. I guess the biggest update, and it sounds like, you know, we're struggling along with everybody else in terms of getting staffing to help implement the program, but we're kind of working through that and trying to get to the point where we have everything lined up and ready to go and start collecting data next paving season.
Okay, so you guys have your equipment and you're planning on collecting next pavement?
That's correct.
Awesome.
Yep.
It sounds like we got to get these robots going here we don't have enough people to collect the data.
Right.
Okay. Washington DOT, Kim or anybody else, anything to share? Kim had reviewed the work plan and gave good feedback for the UNH contract, so thanks for that to the Washington DOT. Sounds like nothing to share at the moment, though. Wisconsin DOT, Michael or anybody else, anything to share?
Yeah, this is Mike. You know, I think first of all, I guess we got into the pooled fund this year, so this was all pretty new to us. We went in, got into the pooled fund, and then right away got the loaner equipment from Federal Highways, which was great. You know, we had it for probably, I think it was about 6 weeks. We were able to get out on 3 different jobs on our gauge, nuke gauge to core correlations, where we were able to get the DPS out there and try to collect the data. You know, it seems like just like a lot of other states, staffing was kind of an issue. Basically, it was just me. So, and then, you know, getting the labs, it was a lot to ask our regional labs to take time away from their normal work to generate pucks for us. So it seemed like our process probably wasn't in line as far as getting our correlations done, and then, you know, having some data to collect and getting some real-time feedback. So it was definitely it was good to demo the equipment. You know, one thing that I didn't realize too is being a person, you know, by yourself is physically what it takes to transport, you know, a DPS system. You know, when you got the big case and the unit isn't overly heavy, but, you know, looking at it from a program standpoint, we're not always going to have, you know, bigger in stature people out there that can physically handle them. So you got to be equipped to transport them a little bit. So, you know, we had our HMA engineer on the job, some regional pavement engineers out. Everybody liked the feedback that you got instantly with dielectric values and the full coverage that we could get on stuff. So definitely something that we're going to look into. You know, we don't have anything right now, you know, nothing in our budget to buy a unit. Our HMA pavement specifications went through some major undertaking the last, you know, 5 years. So focus probably isn't necessarily on redoing our whole entire density acceptance, but being a part of the pooled fund is good for us. It's exciting for us, and I think you know, hopefully in the future we can get a unit and keep moving forward. So
great, thanks a lot for the update. A lot of good information there. Let's keep going. So that's the financially contributing agencies. Rich has been a huge technically contributing person and agency all in one. So Rich, I know you've been doing some work with the pucks. Is there anything you'd like to share with the group?
Yeah, Kyle, thanks for the opportunity. It's been wonderful working with you and all the folks in Minnesota and all the people in this group. So I appreciate that opportunity. This year we are working on a new mix design to resist our studded tires up here better. So it's going to be 6 or 7% oil, 3% air voids when we compact it. We're seeing pretty good results in the Prawl test, which is a test for damage from studded tires to mix. So we have actually written a spec. We've written a new asphalt spec for just this type of mix. It's our new 412 spec, and we actually have a specification now. It's a recommended addition to Alaska DOT and PF standard specifications for highway construction for asphalt, paving compaction acceptance via continuous full coverage dielectric profiling system data. So we're actually rolling out this spec with this new mix that will be on our very high volume roads. So if anybody's interested in a spec where we roll this into our PWL spec, we define what continuous full coverage data is, how many points, and then we do the same thing for joints. So we have it for the mat and for the joint. So that was a pretty big effort that we completed in August. But we don't have any mix made yet. We haven't put any out on the ground, but hopefully next summer I'll get to play with the equipment again. And I'm like Wisconsin, I'm the only one doing anything with it here. So I'm a one-man show here. And I tacked this onto my regular job, so I haven't had a lot of time to work on it. So
well, you get a lot done. So
yeah, well, I work pretty hard, but
yeah,
hard work only goes so far when you're short doing it on any staff. So
well, that's why we're getting those robots going, Rich. So
yeah, I'll be in line for one of those probably, Kyle. Thanks.
All right, there we go. Thanks a lot, Rich. Anybody from Florida DOT, Guanming? Okay.
Hey, Carl. This is
yeah.
Yeah,
Great.
from the DOT. Yes, I'm creating the peer exchange in the conference. Florida, we have the device, but we mainly use for the the forensic investigations. We haven't.
Oh, we lost you, I think.
Can you hear me?
It's getting staticky, but now I can hear you though.
Okay. Yeah, Florida, mainly used for the forensic investigations. So we haven't, implemented, this technology on the production yet, paving production yet. So in the future, we are still debating on this technology, and hopefully in the future, we can, once the condition is ready, we can implement this technology on the production. Thank you.
Oh, very good. Thanks for the update. We're actually at our 12 p.m. time slot at the end. I did give you an hour break, so if any of the loan program agencies who haven't spoken already want to give an update now, and if anybody wants to hear that, please feel free to stay on. Otherwise, please close out of this session when you're done and reopen the next session, which starts at 2 p.m. Eastern time. And we're looking forward to a really great session in the afternoon too. So with that, if you want to go take lunch now, great. Otherwise, if you can stay on, I'll see if there's any other loan program agencies who want to give an update themselves too. So South Carolina, Cliff, or anybody from South Carolina. Okay, how about Leslie mentioned that Nye from Arizona might want to give an update. Anybody from Arizona?
Yeah, thanks. This is Nye. Can you hear me all right?
Yes.
Okay, good deal. So yeah, we've had it here since towards the mid to end of September. We've had it out on a few projects. And I think the learning curve that we've experienced is maybe initially kind of steep, but you get the hang of it pretty quickly once you're familiar with the user interface. We've attempted mixed calibrations using gyratory pucks as well as field cores. We've kind of struggled with the field core calibration. But I think one of the challenges we've got is our mixes are Marshall mix designs. They're not typically a super pave or gyratory. So we're often in the lab and we've got to kind of do some additional work to try to get the initial weight of our specimen and the height worked out. And sometimes that takes a few iterations. So we do see a little bit of deviation, perhaps a little bit more than I'd like to see in some of our attempts to calibrate, but for the most part, we're up there with the R value, you know, close to 1, if not 1, on the laboratory compacted pucks.
Great. So,
Yeah.
okay, so you're talking about you guys are developing the curve with the production mix pucks. That's great.
Right, and then I've noticed if the production out in the field, if that mat tends to have a little bit higher air voids than perhaps the range, or it's kind of trending towards the higher end of the air voids than perhaps what you've calibrated for. And it seems to me that the linear, the straight line calibration seems to work better to fit the data than the exponential.
Definitely.
Kind
Yep.
of seems like if you're on that exponential curve and you've got any readings that are a little bit towards the high end, they climb very high in terms of air voids very quickly.
That's our experience too. Yes.
Yeah,
Yeah, we're
so-
using the linear currently. So
Yeah,
that's a good
so-
observation.
Yep, so I like the linear curve. You know, I think initially we underestimated the effort it would take to push the cart down and back. You think you can get it done in 45 minutes or a half hour, but when you factor in, you know, all the things you want to pay attention to and make note of, and especially other people out on your first few projects that are interested in conversations you have, they're going to spend the whole day out there pretty much scanning in a lot. So that might just be from being a little bit new at it yet, but I'd expect to cut down on that time. But I think we underestimated that initially. So it does take a commitment to be able to get out to a project and get things scanned in.
So it sounds like you're on projects that are fully closed to be able to go collect after the fact.
So for the most part, yes and no. We've had one project where we did have temporary concrete barrier up. We could work behind it, but largely I've kind of had to sneak into lane closures before and after. So let's say after paving's complete and before the coring crew comes out to take the cores. So you are kind of limited in your time that's available to get out to the project to obtain the scan information. And that is a little bit of a challenge. New construction without traffic would probably be a lot easier, but if you're on a pavement preservation project, that becomes more challenging to coordinate time.
Yep. A lot of good stuff there. We also have, before we get to additional states here who have the equipment, is anybody from Massachusetts DOT here? Mark or anybody else have anything to share?
Good afternoon.
Hi.
So we had a great experience with the piece of equipment. It was great to get out there on projects and see how it works. And similarly, we had contractors who did what we were with it, but it was a great tool. Definitely user friendly. I thought, at least after the setup. The setup takes a bit of time when we were out there. I had to do it on kind of like the side before we brought it into the project itself, just for lack of spacing. But overall, it was a great experience that we had.
Good. That's great. Were you guys able to do any coring or any sort of correlation of the dielectric to density?
So we did. That was one major thing that we tried to focus on. Was we got all of the calibration pucks made. We would do the PQI, a PQI reading along with the distance and time reading with it, and then the entire length of a mat too. So we tried to get as much data to kind of correlate how it would all go together.
Great. And I see this is Maggie speaking, is that right?
Yes, that's correct.
Okay, well, thank you very much, Maggie. Okay, I think that's all of the loan program agencies. Di had a good comment in here that Hawaii and Georgia also have the equipment. Is there anybody from Hawaii or Georgia that could give an update? Okay, well, another successful morning session, and thank you to all of you who've stayed with us for the 8 minutes late. So I really appreciate your guys' time, and we'll see you again coming in this afternoon session. So thanks again.